Hey everybody, today what we're going to talk about, you can see at the top of your screen, is the concept of first differences. And so where we're coming into this topic is we've spent some time now dealing with a scatter plot, and so we have an understanding of being given a table of data and then taking that data and producing a graph based on it. We're then fine to start analyzing trends with that and correlation and to talk about whether something is a strong correlation or a weak, whether it happens to be linear or non-linear, whether it happens to be positive or negative. What we want to do today is we want to take a look at a table or multiple tables. And we want to be able to walk away at the end of today with, if I am given a table of data, can I tell whether that data would represent a linear or a non-linear relation? If we can walk away from that today, then we've got everything we need. If we can walk away today with, hey, I can also tell whether it's a positive or a negative relationship, then that's a little extra bonus. So what I'd like you to do, take a look at the screen right now, and I have given you an example where we have a stone that's dropped off the top of a very tall building. I have given you two sets of data, so I highlighted that in blue. Two sets of data are recorded and shown. I want you to take a look at Table A. I've highlighted in pink that what Table A is measuring is at different time periods, what is the speed of that stone? So I want you to notice the time column in your table. At 0 seconds, what was the speed of the stone? We recorded at 1 second, the speed of the stone, 2 seconds, and so on and so on. What I also want you to do then is to take a look at Table B. In Table B, you'll notice that what we have is at different time periods, what was the distance that the rock traveled, the stone traveled. So you'll notice in purple I highlighted, we're measuring something different now. How far did the stone travel? Okay, I want to jump into both of those tables and let's examine some of that information. Okay, so what you see is, all I've done is I've zoomed in a little bit on Table A and Table B. And I've given the instruction at the top that what we're going to do is we're going to complete our first difference column. Now, don't worry if you're like, what is a first difference column? We're going to walk our way through it. What your first difference makes reference to is we want to come up with the difference in the positions of the data. So I want to focus in on the first two rows. We recorded a piece of data that said at 0 seconds, the stone was traveling at a speed of 0 meters per second. But we then also recorded that at 1 second, the stone was moving at a speed of 10 meters per second. Those are our first two data points. I want to examine those two. Okay, the first difference says examine the differences between those 2 points. So we're going to examine those differences. Now, what does the difference mean? Really, that difference means, how do I move from one point to the next? So if we were to graph the data in that table, you guys could easily look at that and see whether that data was a line or a curve. But we don't want to have to produce a graph all the time, because that can be time consuming to produce scatter plots all the time. So what we want to be able to do is to look at a table of data and tell, is it linear or nonlinear? Is it a line or is it a curve? So I'm going to look at my pink data point and my blue data point, and I want to see how do I move from that point to the next. So let's take a look at the first column. My time is my independent variable, and that would lie on my x-axis. So how do I move from one point to the next? Well, you'll notice that I went up 1 second. So 1 second went by. Now what I want to do is I want to look at what happened on my y-axis. My y-axis would be my dependent variable, that is my speed. So what did I do there? I noticed that I went up 10 meters per second. Now, really quickly, what that would mean is that my first difference would be 10. Okay, but how do I get to that value? I'm going to put in a little calculation for you, just so we can see how we actually arrive at that value. Really what I'm doing is I'm taking my position of my blue point that had a speed of 10, and I am subtracting from that my position at my pink point. Oops, I need to put that in pink. Then I'm going to compare my position, my time, at my blue point, and subtract my time at my pink point. Just quite often, you're not going to do any of that calculation written the way I just wrote it. Instead, what you're going to do is you're just going to determine what we did in orange on the table. Look in your column A, you went up 1 second. Look in your column B, I shouldn't even say column A. In your time column, look in your speed column, we went up 10. And therefore, I have 10 over 1. So I am going to include that. I have 10 over 1, which I calculate to be 10. Okay. That is how I calculate a first difference. Now, I am not saying that you should be sitting at your desk working on this going, oh, I now understand what first differences are. No. And I'm not saying that you should absolutely be going like, oh, and I understand how I can tell whether it's linear or nonlinear. No. But what we were able to do was to calculate a first difference. Okay. What we just examined then was how we moved from one data point to the next. What we want to do now is move from one data point to the next. So notice, now I'm going to move from my blue point to my pink. So what did happen to my time? I went up another 1 second. I went up another 10 seconds. So if I calculate my difference, 10 divided by 1 is 10. And what I can do now is continue that process throughout the rest of my first difference table. So a couple things that I want to step back with now that we know how to calculate a first difference. You will notice that your first difference column is staggered. And what I mean by that is it doesn't fit in line with any of the rows in your table. It actually covers 2 rows because a first difference is made up of 2 points. So those 2 points came together to give me my first difference. These 2 points came together to give me that next first difference, and so on and so on. So my first difference column does not line up with any rows. It's staggered. Secondly, I don't think that we can or need to do all of those calculations we just did. We could actually probably go pretty quick and say, well, I know that I go up another 1 and I go up another 10. That makes that first difference up 1, another 10, up 1, up another 10. And we very quickly see that my first difference column is 10 all the way down. That allows me to make a very important claim. Therefore, that data is linear. Now, I want to take a step back and I want to make sure that we're good for why that's the case. I don't care that it's 10. 10 is not a magic number. It could have been 2, could have been 5, could have been -6, could have been 1,000,000. Who cares? But you look at every single one of your first differences and they are all the same. So why does that mean linear? I am going to draw the crudest of scatter plots. I'm going to put a quick set of axes down. And I don't even care if I'm relatively accurate. I have a first data point that was at 0, 0. My next data point was at 1, 10. What that meant in my table is I went over 1 unit and up 10 units to move from my first data point to my second. Well, look at what happened in my first difference column. My next difference was also 10. That means that I went over 1 and up 10. There was my next data point. My next data point was here. My next data point was my next. And you guys can maybe see that the reason why it is linear is because I was moving the exact same way between every consecutive data point. That is why it is linear. Okay, let's jump into table B. You've done a little bit of work with some scatter plots and being able to look at that data and see whether something is linear or nonlinear. Let's be a little bit better now with table B. We know how to calculate first differences. So if you're feeling comfortable, I want you to pause the video now and try to calculate all of those first differences. Okay, pause it now. Okay, we're back. So let's get a little confirmation. In my second table, I went up 1 second and up 5 seconds. So 5 divided by 1, there's my 5. My next movement between my data, they were a second apart, but now I was 15 meters apart. I am hoping right at that moment, you could now tell me that that is non-linear. And if you can, I think we have a really good grasp of the concept. But let's just finish it off as we go. My next first difference would have been I went up 1 second, I went up 25 meters. I went up 1 second, I went up 35. I went up 1, I went up 45. And maybe pretty quickly we can see why that would represent a non-linear relation. To go from my one data point to my next data point, I went over 1 and up 5. But to get to just my next point, I went over 1 and now up 15. Maybe we can see that those 3 points do not line up. Well, my next data point was going over 1 and now up 25. Well, pretty quickly you can see that if I were to connect those would require a curve, let alone all the other points. So the takeaway I want us to have from those first 2 tables, I can tell whether a relation is linear if all of my first differences are the same. If they are not the same, even regardless of whether there's a pattern, like you can see, there's a pattern there, but they are not the same value, therefore my graph is not a line. It is nonlinear. Okay, if my crude drawings at the bottom did not do enough to kind of show us, then let's just take a quick peek at what those scatter plots would have looked like if I had produced a proper scatter plot on a grid. Okay, so what you see then, if I was to produce my speed table, there's both of my axes, vertical axis, me measuring speed, my horizontal axis is where I always put my time. There are my data points plotted in my blue highlights. Hopefully we can see that now that pink first difference column says I go over 1 unit, I go up 10 units. Over 1 unit, up 10 units, so on and so on. Because I was doing the exact same thing, moving from point to point, all of those data points would line up exactly. And so even if my data continued, maybe off my grid, I could make some assumptions about the direction of that data. Okay, there is my formal scatter plot for my speed table. We'll take a look at the one for our distance table. Okay, so you see a quick scatter plot, a little more official though. We've got it on the grid. My data points are again plotted in blue. And again, we should be able to see that those points do not line up, and I can tell from my difference table that they will not. I went over 1 and only up 5. My next point went over 1 and up 15. Over 1, up 25. Look at the difference between those vertical arrows that I keep drawing. That is telling me that I am not going up the same amount, and therefore those would connect with a curve rather than a line. They happen to be perfect in their relationship. Like, it's not a zigzag that puts those together. It is a smooth curve, but it is not linear. So hopefully taking a look at both of those scatter plots, maybe give that sense of we can actually see what's happening to our curve from a linear, nonlinear, based on our first difference table. Okay, let's get a little bit more practice with those first difference tables. So in your note, now that we've kind of talked a little bit about it, let's just get down some key terminology. First differences are differences between y values in a table of values. The x values in the table are increasing and consistently spaced. Look at each of those tables I gave you. Every single one of my x values, or in this case t values, they all go up by 1 each time. Those are consistently spaced. When they are consistently spaced, then I look at that first difference column and I can see that if the first differences are the same, then my relation is linear, and if they are different, then it is nonlinear. So your job, you want to be able to complete a first difference column and be able to tell me whether that is linear or nonlinear. Okay, so what you see in front of you is you have your table of values. And now what I want to do is I want to go through and complete that first difference column. So I think some of us are going to feel pretty comfortable to be able to go through and deal with that. So give it a shot. If you're comfortable, pause the video and we'll see if we match up in the end. Otherwise, we're coming through this one together. I will say there is a little bit of a quirk to it. We're going to see how closely we were paying attention to those details. So let's calculate our first differences. Well, I take a look in my x column, my first column. And I see that in that column, I increased by 2. My y column, I increased by 20. That means that my first difference is 20 divided by 2. My first difference is actually 10. I think you have a good understanding if you said that your first difference was 20. We were just missing that little detail of, oh, wait a second. My x values are not going up by 1 every time now. So just be careful and we can make the adjustment and we're good. So if we're on to that, I would say pause the video and see if you can finish it off. Otherwise, we notice we went up 2, we went up 20. 20 divided by 2 is 10. And we're probably not even writing that in anymore. We notice we went up 2 and up 20. 20 divided by 10. Please feel free to just show that calculation in your first difference. Up 2, up 20. Now, everybody, as they're writing this, should be going, I'm thinking that this is going to be linear because I have the same first differences. Don't stop short. We need to make sure that every data point is the same difference. So I continue all the way down my table, and I have to confirm, yes, look at all of those first differences. They are all the same. And therefore, I know that that is a linear relationship. Okay, I really don't think there's anything else that I can throw at you guys. The rest becomes practice for us. So let's see how it goes. You see problem B. Same thing. Go ahead, complete your first difference column, and then determine whether that is a linear or non-linear relation. Give it a shot. Pause the video now. Okay, we're back. So you'll notice our X column now has a couple negative numbers that shouldn't be that big of a deal for us. Let's keep working our way through. So how did I move from my first data point to my second? I went up one value. To go from -2 to -1, I went up 1. I went up 2. So I am 2 divided by 1, 2. Well, quickly I kind of look at it and I go, but wait a second. Look at all of my X values. I'm going up by 1 every time. So it's not like I can ignore my X values. I've actually paid close attention to that. But what it means now is when I'm calculating the rest of my differences, I only have to focus in on my Y values. Okay, so what's happening between my first two? I went up 6. I then went up 18. Okay, the numbers are getting a little bit bigger. So if you need to calculate it, calculate it. My 81, subtract my 27. But maybe we're able to work our way through and see that we went up 54. Take your 243, subtract your 81. We notice we went up 162. Take your 729, subtract 243. We went up 480. Okay. I want you to take a look at that because I just want to highlight something really important. I'm hoping we can all say that that is obvious, that that is non-linear. But at what point do you get to make that statement? Well, if I didn't ask in the question to calculate the first differences of each table of values below, and I just gave you that table, you don't have to fill in the whole thing. Because I asked you to calculate your first differences, you have to fill in everything. But let's say that that blue wasn't there, and I just gave you the table, and I said, determine whether it's nonlinear or linear, and give me some proof. Well, then you could have stopped right there. As soon as you found that your first differences between your first two data points was 2, and then your first differences between your second two data points was 6, as soon as you saw that those were different, you could have stopped. Now, I don't recommend it, because what if you made a silly little mechanical mistake? What if you didn't pay attention to your X values, and to go from your second data point to your third, what if that X value was 2? You would have now gone up 3 And when you calculate 6 divided by 3, you get 2. Oh, shoot, they were the same between the first two. We could have missed that. And so although we could have stopped after we calculated that first difference of 6, my recommendation to you, fill in the whole table. It doesn't cost you a lot of time, and it definitely should show you whether something is linear or nonlinear. Okay, let's keep it going. You take a look. There is a first difference table for you. You'll notice I've just removed the slots to see, are you good at being able to work with it? What I want you to do, calculate your first differences, determine whether it's linear or nonlinear, okay? Everybody should be trying this one on their own. I want you to pause it now. Okay, we're back. So you take a look down your X column, and you notice every single one of your X values are going up by 1. So I don't have to worry about dividing by 1. So I'm going to examine my Y values. Those two first differences, between here, I went up 3. Between here, I went up 5. And you notice that if I draw my differences that way, I'm actually staggering my first difference column. So if I was to go and put my little slots back in, you can see that those values now stagger as they should. A little recommendation for having to produce a first difference column where I don't give you the actual rows for it. Okay, we get down to that, and we should all be very good to say nonlinear. Even though there is a pattern between those points, they are not the same. Therefore, it is not a line. Okay, last one. Last table, you should be good to pause the video and give this one a shot. So, pause the video, see what we come up with. Okay, we're back. So, I take a look at my X column, and I see that I'm going up by 1 every time. So I am comfortable then to go through and examine the difference in my Y's. To go from 2 to -1, I actually went down 3. To go from -1 to -4, I went down 3. I went down 3, and I went down 3. Well, I don't care that I got a negative value. I was consistent in every single one of those values, and therefore, it is linear. Where I want to draw your attention was the extra add-on that I added or mentioned at the beginning of the video. I actually have a little bit of extra information. You will notice that in every previous example, my first differences were always positive. And what that tells me then is my relationship is positive, whether that is a line or a curve. What I just found in this relationship is that since my first differences are negative, my data is going down. In this case, it's going down in a linear fashion, so it is a negative relationship. If it was negative values, but they were changing, then maybe I've got my curve. Okay, I threw a bunch of stuff at you with respect to first differences. Hopefully we can see why they tell us whether a curve is linear or nonlinear. Your job, get a little bit of practice with it and make sure that we're comfortable in determining that table. Okay, good luck, guys.